Hi, I'm Christopher Schwarz and I'm the editor of Popular Woodworking magazine. And one of the most popular classes that I teach on weekends is how to build a saw bench, which is this little device down here. And so we thought it would be a good idea to take this class and make a DVD of the process of making this essential piece of hand tool shop equipment. But the problem is that on DVD, sometimes I think I look and act like a lab animal. So we decided to do something a little different. And instead of just shooting me building this saw bench, we decided to do it with a class of 10 people. So for the next hour or so, you're going to be following along with me and the 10 students as we build this project almost entirely by hand. And I bet you that at least once, Megan will get bleeped. Okay, well, this is what we're building today. And this is a traditional English style sawing bench, also called a saw bench. Some people call them mortising benches, but actually mortising benches are a little different, and that's another class. Saw benches are tuned in a very special way to work with a handsaw and with a rip saw. And you are going to make your saw bench for you. And when you get home, using the instructions provided, you're going to make a second one because they always come in pairs. And so this directions will show you how to build its mate. Now, saw benches are absolutely genius, I think. And they are genius because of their height, for one. And their height is directly below your kneecap. So let's measure. Let's have a volunteer. Okay. So every saw bench is a different height. So here we have this saw bench. Sorry, don't take it personal. We're going to make his about 20 inches high, which seems pretty low because mine is, nope, actually, your saw bench is going to be higher than mine. You have bigger, what bone is that? I don't know.
Yes.
That bone is bigger than my bone. So we're going to make it that specific height. And the reason it's that specific height is so that you can use it effectively. The genius thing about saw benches is that you use no clamps when you're working, is that this knee clamps down and this knee controls the motion laterally of the board, so that when you're sawing and bringing the saw closer to you, is that it can't move because it's up against this knee and it's held down by this knee. No clamps. Very genius. Now, the other thing about the saw bench that's great is that it is tuned to your body and your height and your saw. And remember, the saw blade is about this length. Most saws are used when cross-cutting at a 45-degree angle. So at a 45-degree angle, I can't hit the floor, ever. And at a 45-degree angle, I can't unless I pull my arm out of its socket, I can't pull the saw out of the kerf if I'm sawing properly. So that is the special genius of these things. Now, they're not just used for sawing, and we use them all the time in pairs for assembly. We assemble cabinets on them. We assemble panels on them. They're used for just about everything. But traditionally, they're also used for sitting on them for eating your lunch. And you think I'm crazy, but that is always mentioned in the old books. So they're a very handy place to sit. And when you do make them, you have to make sure that other members of your family don't claim them for their own, because they are also, they'll use them as step stools and all the like. This design has evolved over several generations to make it lighter and lighter and use it with fewer and fewer materials. And we're down to using it, basically a 10-foot long 2x6 creates this. And this is the handy way to carry it, tucked under your arm. And we have only one stretcher here instead of two stretchers on earlier generations, so that when you're ripping, you don't score the stretchers. The other feature that a lot of people ask about is the ripping notch, which is the little bird's mouth here. And that is for a lot of different things, but mostly it's for ripping thin materials for supporting it, or when you need to make really short rips, you don't want to cut into your saw bench, so you do the short rip right here. But I use this a lot of different ways. Sometimes I will take it and ram it up against my bench top, and then you can actually put a whole frame and panel entryway door wedged into this and plane down the edge so it will fit inside its jambs. I'll take cabinets and put cabinets on top of there, and then plane the tops of the cabinets off, because the cabinets will be raised up against my bench. I'll put a table leg in here when I'm trying to lower the table apron down to the top. I mean, you'll find all sorts of crazy uses for it. And so this is what we're going to build, and we're going to build it using all the special forms of saw cuts that we're going to learn about today and tomorrow. And so by the end of it, you will have learned a lot more about sawing, and then produce a thing that will make sawing easier for you when you get home. So I'm going to show you how to mark the parts, and then we're going to start off by cutting the angled notches on the legs, which looks like the hardest part of the whole thing, but it's actually cake now that we know a little bit about sawing. This is supposed to be a class in hand tool joinery, but you can't do a hand tool project without learning a little bit about how to approach your work in a proper and hand tool manner, because it is almost the exact opposite of the way you approach a project when you build it by machine. When you build a project by hand, every piece of wood has different surfaces that mean different things and have different things done to them. So when you have a surface or a board in the hand tool world, you're going to have a surface that is going to be your reference surface. You may call it your datum surface. There are all different sorts of names for it. But it is the surface that has to be true, has to be flat, because it is going to be interconnected with the other parts of your project. That means, for example, like if it were a case side, the inside of the case side that has the dados and the rabbets and the grooves, it has to be perfectly flat. But it doesn't have to look good, unless you're capturing people inside who are going to see your workmanship inside your cabinet. But so this surface needs to be flat, but it can look terrible. The outside surface has to look good, but it doesn't have to be flat. And so that is going to be the show face. So every piece of wood has to have one reference surface and one show surface. Sometimes they're the same surface, as you're going to see as we move through this project, and sometimes not. So if we look at the first thing we're going to deal with on this saw bench is we're going to deal with the legs. And so we need to true up our legs so that we can create the joinery on them to interconnect with the top and with this stretcher down here. So if we look at this piece of leg, what I'm going to do is I'm going to choose the ugliest surface to be my reference surface, because this surface is on the inside of the leg is what I'm going to put my joinery on so that it relates to this notch in the top. So I'm looking here on this. Well, these are both fairly ugly surfaces, but I determined that this is the most ugly. And so this surface I'm going to get as flat and true as I can with my planes, and then I'm going to make a mark on it like this. And that mark means that this is the reference surface. Then I'm going to have a reference edge on this. And as we know, we have this stretcher coming in here. And so this surface needs to be true and 90 degrees to this surface. So what you're going to do is you're going to say, okay, if this is the top of my leg, then this surface is going to be my show surface. This surface is going to be my reference face, and this surface is going to be my reference edge. This surface doesn't matter so much. It's got a little bit of mating up here to do, but it's mostly just, all for show. And this surface is all for show. This doesn't have to be flat at all, it just has to look good. So what I want you to do, the first thing I want you to do is to make this flat with your planes, as flat as you can get it, and then make the adjacent surface 90 degrees to it using your planes. Now, I will do this with a joiner plane, but these surfaces are so small that I think you can do it with just about any plane would work. So just put it up against a stop, and so then after I clean up the machining marks, I'm going to check it with my edge of my plane. Make sure that I didn't create a hollow in it or a hump. And so this is my reference surface. So what I'm going to do is I'm going to do this. And this line is going to point to my reference edge. So now I'm going to dress my reference edge. The dangers of working against a single point stop. And then I'm going to first check that along its length to make sure I didn't create a banana. And then I'm going to check it for square. The stock of the square goes against your reference surface. So this has to touch the place that has the mark. And then I'm going to compare it all along the length to make sure that's 90 degrees. This corner is high a little bit, so I'm going to take a shaving there and then check it again. And that looks good. And then I'm just going to make a mark here, and this mark meets up with this mark. So now I know that this is my reference surface, face on the inside, my reference edge on the inside, and I can dress these other two surfaces just so they look good. I don't even have to check them. Just remove the machine marks. So don't spend a lot of time on these two. Just clean them up. Okay? So that's what we're going to do first. So let's go grab our legs.
Does anyone need a plane?
And make them flat. The leg notch is at a 10-degree angle with a 10-degree little bird's mouth in it. And that seems like it would be something very difficult to cut. And it would be on a table saw. We'd have to make a jig. And make a jig to make a jig to make a 10-degree by 10-degree cut. But with a handsaw, it's going to be very simple for us. And the leg notch is what controls the splay of the legs and makes the whole saw bench more stable. So what we're going to do is, this is what the leg notch is going to look like in the end. And the first thing we're going to do is we're going to set one gauge to 1/2 inch, and we're going to mark the top of the end grain with that gauge. Then we're going to either reset that gauge or use a second gauge and mark this shoulder at 1.5 inches. And then the third thing you're going to do is you're going to take your bevel gauge. You're going to come over to my saw bench, or if you can just instinctually, get 10 degrees in your head, which I don't recommend, set your bevel gauge to 10 degrees off of 90, and keep it locked there. Lock it tight, because this is going to guide you through the rest of the project, and then guard it with your life. So let's go about making that. The first thing you have to do before you can make this mark, though, is you need to decide what is the top and what is the bottom of your legs, and how are your legs going to be oriented. And the way I always do this is with a cabinet maker's triangle. A cabinet maker's triangle that you scrawl on the top will always point towards the front of the top, which is where the top of the triangle is. So that's going to point to where the bird's mouth ripping notch is. And you're always going to know what is, the inside, outside, front, and back. And if you do this, if you mark it correctly, then all of your reference marks should be on the insides of these. And everything should match up, made up nicely too, because these surfaces are supposed to be flat. So now I know if I pick this leg, I know instantly that this is the inside edge. And so I'm going to take my 1/2 inch gauge and mark the top of the shoulder, the top of the cheek actually, with this. And then I've got an 1.5 inch gauge, and I'm going to mark the shoulder. Then what I'm going to do is I'm going to take my gauge here, and let's see if I can get this to work like I want it to. And then I'm going to use a knife to go 10 degrees off of my shoulder line at the top. So I'm dropping the knife into the little knife line that carried over on the corner. And then I'm going to turn the gauge around, and I'm going to go 10 degrees down. So I'm going to put it up on the shoulder line that I cut, and it's 10 degrees down. Let me fill that in with a little pencil so you can actually see what this looks like. So that's what it looks like if you want to come up here and take a close look. And then I'm going to repeat that on the other side. So it's 10 degrees down like this, and then 10 degrees down like that. It looks like a little check mark. And then I'm going to do the same on the other side. Make these with a knife. And knife cuts are far more accurate than a pencil line. And manipulate your gauge, your bevel gauge here, so that you have the maximum amount of bearing surface on the top of the leg. And when you knife in the joints, it's much better to use 4 or 5 really light cuts than one mighty stroke. And then we're just going to darken that in so that we have a little more visible line. Since none of us are getting younger or getting better eyesight. Okay, now we're going to saw this like a tenon cheek. So you want to put it in your vise, in your face vise, and you want the waist facing you. You want to get used to that configuration. Don't sometimes put the waist facing the bench and sometimes the waist facing you, because you need to train your body that the waist should face you. And that's the easy thing to think of and the easy way to remember it. Now, when you saw a tenon cheek, you are wanting to saw across 2 dimensions at one time to make it more accurate. It's much harder if we came in from the top to just saw straight down from the top and down to the bottom to be accurate all the time. It's far more accurate to advance on 2 lines at the same time. That's the traditional way to cut a tenon cheek. The problem is that we need to start this saw on the corner. And starting the saw on the corner is tough because we have a triangle here and our teeth are a triangle. And so instead of cutting each other, they're going to want to kiss and spoon, for lack of a better word. So we need to do something about that. And we also need to make it so that the saw will start accurately. In hand tools and in especially sawing, you're going to find that the better you start, the better you'll end. So if we start right, we'll end right. The way you do that is what Robert Waring calls a second-class saw cut. And this is where we create a notch using a chisel that's going to guide our saw as we begin the cut. So here's how you do it. You take it and you put the bevel towards the waist and come up. And I'm just going to drop it in that knife line on the corner. And then I'm going to press down a little bit. Don't do it with a mallet. And then I'm going to come around with the same chisel and I'm going to cut or pare out a little triangular shaped piece of waste. Now what we've done here is we've created this V notch like this. And this is our tenon. This is our keeper side. So we have this fence that is going to prevent the saw blade from leaping over into the part that we want to keep. And we have this slope that is going to encourage the saw to push down, to ride down right up to what we want to keep. And then the third bonus is we've created a flat place where we can start the saw so it's easier to start. So these notches are very handy. And this is what is called a second-class saw cut. And second-class saw cuts are used when accuracy is paramount, but the final appearance of the joint is not. You know, it's not a show face or a show surface. So I'm going to use all my sawing tricks. I'm going to hold the saw as loosely as possible. I'm going to take all the weight off of the toe, and I'm going to begin this cut. So here I am right at the toe, and I'm just going to gently start with a couple strokes forward. And then after I get a couple strokes forward, what I'm going to do is I'm going to start sawing down this end grain to create a sort of a starting notch that's about 1/8 of an inch deep all the way across the end. So here we go. And I'm going to do that by blowing on the line so I can see the line, and I'm using my thumb as a fence. And I'm moving my thumb forward as I advance on this line. Do very accurate work this way. Now, as soon as I get to the other side and are about 1/8 of an inch deep, then I can begin tipping the saw down this way, and I can begin to worry less about the way the saw is tracking here, because it's going to follow the path of least resistance, which is the little kerf that you created. And you can focus your energy and attention on following this line. Once I hit my baseline, turn it around. And the saw is going to follow the path that I created on the last cut. And when I hit my baseline on both sides, then I'm done. And now we want to cut the shoulder. Now the shoulder is at a 10-degree angle, which would be a difficult cut to jig up, but it's no big deal for us because, you know, if we can see the line, then we can cut it. So I'm going to secure this to my bench with a hold fast. If you have a bench hook, this is a good place to use a bench hook, but I always like to really secure it down tight. Probably should have a pad or something under here, but you know, this is the reference surface, it won't show, so I'm not going to get too haired over about it. Now, this surface is a show surface. Not really a show surface, but it's a critical surface. You know, it's on the inside. But the shoulder line is going to determine exactly how the leg is going to mate with the top. And so we really want to take some care. So we're not just going to go hacking away at it with a saw. We're going to do what is called a first-class saw cut. And this is also a Robert Waring trick. And you want to create an environment that will allow you to start very, very easily on that line. And so what I'll do is you take a wide chisel, the widest chisel you have, you drop it into your line, and then either in pine you can just use your hand, but in hard oaks you're going to use a mallet, and you just give it a couple big knocks to deepen that line a little bit. So, and then you come back with your chisel and you pare out a little notch. So what I've done is, once again, I've created that V like we did on the second class saw cut, but I've done it all the way across the shoulder line here. And so now my saw can just drop into that little notch and start without a lot of jumping around. And the other beautiful thing is, if this were a show surface like the outside of a tenon, then we will have already made a very nice clean shoulder cut, but with a chisel instead of a saw. So we've already cut the shoulder. So the first class saw cut is actually a chisel cut. So I'm going to take a crosscut saw with relatively fine teeth. This is a sash, and I'm just going to drop it in. And that's it. We've got a little cleanup here to do at the shoulder with a chisel, but that's going to nest just fine. This waist piece where I started, which isn't at exactly the right angle, is going to get cut away. So don't worry about it. There's extra length here. So the top of the tenon doesn't have to be absolutely perfect, the top of the leg. Any questions? Okay, I'd like you to do that on all 4 legs, and then we'll come back and we're going to learn how to true these up if you mess them up, because you will. I did, first time. When you do have your waist pieces fall off, save those. Those 4 pieces are the best clamping call you'll have when you clamp these legs up. The first thing is, after you finish these leg cuts, is you want to save these guys, because these guys are your clamping calls, as I mentioned before. Don't let other people steal them off your bench. Put your initials on them. Guard them with your life if you must, because you'll thank me for this later. Okay, we have these notches cut, but we're all human, and so these notches might be wonky in some way, and they can be wonky in that this one has a little nuttiness up here at the top because I started down straight instead of at an angle, but it's going to be cut away, so I'm not too worried about this area up here, because this is 1.5 inches long and our top is only 1 3/8 thick, so this is going to probably get cut away. But as I put the 2 legs together, as they're going to be in together, is I want this surface to be, I want it to all be in the same plane. And I don't want any bumps or high spots, because that'll interfere with the way that this matches with the notch in the top. So the first thing I'm going to do is I want to try to get the higher surfaces basically flat, so that I can then true them both together. And you could just go at it with a shoulder plane right now if you wanted to, but everybody who does this at the beginning, they just make like this wacky curvy banana thing. And so I've been trying to come up with a way to make this process more straightforward and easier to do. And what I kind of came up with is, I want you to take one of the hand screw clamps that we have. We have a whole stack of them back here if you didn't bring one. Put them together so the jaws close, and then take your hand plane and plane it so that these are dead flush. Because sometimes they'll be a little bit off. But you want these 2 surfaces to be in the same plane, with the bottom 2 surfaces flat against your bench. And then you want to take the errant, naughty leg in question, and you want to put it so that you have the high spot above the jaw and the low spot, the lowest edge, flush to the jaw on the other side. So here I have a high spot here, and this is completely flush. So I know that if I take a chisel and use this as a guide, is that it'll remove these high pieces like this down to my low spot over there. And so what I will end up having is at least a coplanar surface. It might not be coplanar with this yet, but it will be, it will be flat. And then you'll have much better luck with your shoulder plane in cleaning it up. So we're going to do that. And this, once I get this flat, still got a bump there in the middle. There we go. Once I get this flat, then I can even come in and true up the shoulder if I want to. By putting this flat across here, this is 90 degrees, even though this was 10 degrees off of the face of the surface, it's 90 degrees to this surface. So this wants to be a straight corner. So by running the shoulder plane in there, we can then clean out the junk in the corner and fix any errors that you had when you made this little 10-degree cut. Easy peasy. I hate that expression. The next thing is, once we have them basically trued up, then we can clamp them together like this. And this is how they're going to appear or be together. And I can see that, this I got flat and this I got flat. But this is lower than this. So what I want to do is get myself a dog and clamp them up. And then work on the lower one and bring the higher one down to it by using the lower one as a reference surface for the back part of the sole. And then as soon as the plane iron touches this surface, I know that they're coplanar. And I can check that by using the edge of the plane as a reference, and I still have some work to go here. So this brings them into the same surface, same plane. And then if the shoulders don't line up, once I get them in the same plane, I can come here and bring the shoulders into alignment too. So with the power of the chisel and the power of the shoulder plane, we can fix all the mistakes we made while sawing. A little more to go, but that's essentially it. Any questions?
I started to get a little tear out when I tried that.
Did you get tear out
Yes.
back here? Yeah, you'll get a little spelching. That's what that's called when you pull and you come off the outside rim. It's the British word for blowout. That's what Americans call it. Very American word. Spelching. And we have to say it like that. Spelching. Yeah, you're going to get that. And the way to relieve it is that after everything is dressed up and coplanar, then just plane this side. This edge and get rid of the spelching. We could come in there with a chisel and plane or make a nice little chamfer, relief chamfer. But then we could also knit doilies for all our tools, and we can also do that. So, I'm an American, so I'm going to live with my spelching and then plane it away before I mark my notches on my top. So that's how we're going to clean it up. And I'm almost done here. So when I'm done, I'll come around and give you all a hand. But we're going to cut this ripping notch right now before we get any more work on the top. And I want you to do this because I want you to start moving into getting a taste of the bigger saws. You know, we've used a lot of the joinery saws and the back saws, but you know, sometimes panel saws are used at the bench, and so this is our chance to sort of get a taste of that and how they feel different from the back saws. So we're going to lay out the ripping notch, and the ripping notch is 3/4 of an inch in from the edge. So take your combination square and mark it in 3/4 of an inch in, and then it's 5 inches deep. So find the center line, which will be 5 inches down, 2.5 inches in. Mark a little X, and then on both sides of your work, mark your line. Like that. And then take a ripping panel saw. This one has a rip tooth. It's a 7-point. And 7-point is about right, I guess. I mean, I wouldn't want to, they don't make a lot of finer rip saws. So what I'm going to do is, it's a little different with a hand saw or a panel saw than it is with a back saw, is you begin this cut with a few backward strokes to try and kind of make that second class saw cut notch. So these make their own notch. So we're going to begin there at the corner, and I'm going to work at an angle. I gotta see my line if I want to cut it. Then what I'm going to do is, so I'm following this line as best I can down the front of my board, and then I'm going to use that line to follow it on the back of the board. So I'm seeing this and making a nice notch, and then it's easier for me to follow that line down there. And then when I hit the bottom again, come in at an angle, and then do the same. And then do the other side, same way. But getting that started with a few dragging cuts, that's the challenge with these. You want to use light downward pressure. And when I'm starting these, especially on the bench, I'll sometimes use the back teeth. You know, usually we start with the toe with a back saw, but with these, this is stiffer up here. You have the tote stiffening things up, kind of like a back. And so when I'm working at the bench with a panel saw, I'll definitely start up at the back teeth and then go into using longer strokes. And then the other saw's best friend is the rasp. And you can break those edges. And rasps only cut on the forward push. You don't drag them back like this because that dulls the teeth. And then you can merrily clean that notch until you're happy. That thing sounds like it's growling when you cut it.
Is that bad?
No, it's very animal saw. Now, we need to cut the notches in the top that receive the notches that we cut on the legs. The reason we cut this little bird's mouth is so that it will resist all the downward force when you put your whole weight on it. You can park several thousand pounds on these and they won't crush. Kelly Mailer just put 1,500 pounds on his pair of saw benches that we built when he was getting stock ready for his bench class. And so this little bird mouse notch, which was a pain in the butt, is really a good thing. So the first thing we need to do with our top is we need to decide which surface is the show face and which surface is the reference surface. The reference surface is the underside, so it needs to be the ugly surface. And so we need to dress that side flat. Then we need to dress the long edges 90 degrees to the reference surface. And then the top just needs to look good. So we're going to dress that with our planes. And which is, I've just finished up here while you were working. Don't need to see that again. And then I scrawled a cabinet maker's triangle on the show surface. Here's my mark on the reference surface, just so I can remember, which face should go up. So what I want to do is I want to place these legs in position where they're going to go, to use the legs to mark out the notches. We can measure it all, but it would be wrong. So what we're going to do is we're going to take our top piece, put the reference surface to the front of the bench top, and then I use a leg to help me, get it so that the top is in there and projecting equally all the way across. Reasonably so. And then I want to mark out the outside edge of the notch, and then I'm going to mark the inside edge of the notch using my leg. That way it'll be bang on, whatever it is. So the notch begins 4.5 inches in from either end. So I'm just going to take my combination square, and with a knife, this has to be knifed in, mark that. A few lighter strokes, like I said earlier, is better than one mighty stroke. You're much less likely to follow the grain with your knife if you do it that way. So I'm going to use my other legs to prop this up at the right angle, at the 10 degrees, and simply shift the legs forward and back until this sits flat. So I'm just going to then sit it flat, move them in, and it holds it for you. So you don't have to awkwardly, balance it while you knife. And then I'm going to take my knife, and with a flat face, I'm going to position the flat face so it is facing my leg. And I'm going to drop that in my knife line and then slide the leg up to it. So it just automatically, by itself, references where it needs to go. And then I'm going to come over here and mark the other side. And just to confirm that that's in the right place. So now I've marked that out, and I can put some mechanical pencil lead in there to make it easier to see. Then what I'm going to do is I'm going to take my cutting gauge and I'm going to scribe the baseline for this joint in. And the baseline is 1/2 inch in. So I set this cutting gauge to 1/2 inch and I just scribe that across on both sides. Paint that in. And then I want to take my knife and square. I want to drop the line down. So the way I'm going to do that is, once again, you use your knife line, your existing knife line. So I drop it in there with the flat facing in. I just move the square up to it and then drop the knife. flat towards the waist, drop it into my knife line, move the square over, drop the knife to my baseline. Now I can begin to saw the walls of this notch. So what class saw cut is this? First, second, third, fourth? Anybody? Second? Well, it would probably be a first class saw cut because this is like a tenon shoulder in that it's going to be very visible. So I think we want to, get every trick we can to make this joint look as tight as it can. So what I'm going to do is I'm going to take a wide chisel, drop it in the knife line with the bevel facing the waist as always. Give it a little wrap. And then come and pare away the little V-notch that's going to get us started. Then I'm going to take a cross-cut saw and pick one that's fairly fine. That's 11 or 12 points cross-cut. You want this cut to be nice. Take all the weight off the toe. Now you have a lot of options as how you can remove this waste. You could take a coping saw, you could take a bow saw, you could take a router plane and take it away a shaving at a time. I am, I guess, a little bit more of a brute, and so I just like to pop it out, most of it with a chisel, and then finish up with a router plane. So I'm going to I'm way above the line. So I'm going to leave some waste. So I'm here, I'm like, what, about an eighth, 3/16 above the line at first, just to see how the pine's going to split. And then I'm going to take a couple more whacks until I'm close. The more waste you remove with the chisel, the less work the other tools have to do. And getting good with a chisel is, paramount to good handwork. I think it'd be great to offer a class in chiseling, but no one would come. I mean, it's just not a sexy tool. It's like accurate all work next week. Then we're going to take the router plane and we're going to clean this up, clean the bottom up. Router planes are great because they're like chisels with depth stops. So this router plane, when it's set to this 1/2 inch depth and the depth stop is engaged, it's going to make 4 notches that all have their bottoms perfectly flat and parallel with one another, assuming that your edges are parallel. And that is a really powerful, very, very powerful function and something that the router plane is very good at. So router planes are just used with a sort of sweeping motion. So I work from the outside to the middle on both sides. You can't take off a huge bite, but you can take off significant, you should be able to get it close. So I'm getting it almost to my line. So that's almost to my knife line. And then finally, on the last pass, I'm going to drop the tip into the knife line that I established, and then I'm going to secure the depth stop so that I can return to this depth 3 more times when I cut the rest of the notches. And then just take a nice little cut And I'm working from the outside to the middle to avoid that awful spelching. And now the moment of truth. The reason I hate that the camera's on and 10 or 11 people watching, we get to see how I did. Well, it's not bad. It's not bad. Yeah. Okay. Now you do it. And we'll see. I will applaud. But any questions on that? I mean, it's really, with router plane, it's really simple work. So go at it. We have router planes here that you can borrow, a couple of them. And this one's set perfectly to a 1/2 inch. And let's see what we can do. The key to clamping these up is to take those little shims that I told you to save and tape them to the pads of your clamp. And you want to make sure that the thick part of the taper is at the top and the thin part, hey, it could happen, somebody could mess that up. So you got to say it. And so you get your clamps arranged like that. And then you get some glue. Yellow glue is fine. And you get an assistant. And so what you do is make sure you know what your top is, and that's marked so you don't accidentally put it in upside down. And you grab your glue, paint each notch. Better to use a little too much glue than too much glue than too little. And be sure to get a little bit on the walls. Even though the walls are end grain, there's still some holding power that you can squeeze out of there. So why not? Don't just ignore them. Okay. And then you want to get the mating legs. And these two. And you want to spread glue on those as well. You want to make sure that, there are no dry spots, because this has to be a good joint. Would you mind spreading that, lovely assistant? Later on, we'll be sawing Megan in half, which is a first-class saw cut. You got to work fast because you don't have much open time with this yellow glue. I need that more than that. All right. So you have these, which go on the other side. So hold those for a second. And these go on this side. Always check your Now I'm going to turn this over, Megan, and then if you could then place those, that would be great. That's the back one. Okay, you got it? In?
Nope. Excuse me.
Okay, that'll get in. So hold both, and then we're going to set it, squeeze them. We're going to set it up. Okay, just like that. Now what we want to do is push it down onto the bird's mouth shoulder and be looking in there to make sure that we're really up against it. Yeah? No?
There we go.
Okay.
Nope, not that one.
Okay, we'll use the clamp to spring to hold that one up. Okay, so hold things together. You got it? Okay. Okay, hold it right there. And this clamp is, of course, we're going to have to cut. Yep, this pad needs to be moved down. These clamp pads are longer than I thought. Thank you. I have pipe clamps at home. Okay. There we go. It's an easy fix. Put the pads right over that, and then begin to squeeze. Okay, now hold it. Hold the legs. Ready?
There you go.
Okay. And then you're done. Walk away.
And come do your crosscut.
I'm sorry?
And then come do your crosscut.
And then come, yeah. All right? Not too hard, but we do it in groups.
Now we watch it dry.
No, we don't watch it dry. We help our other friends. We let the glue dry. We let this dry overnight. You don't have to let it dry overnight, but it doesn't hurt. And now we have a choice. We can either go ahead and put on the lower stretchers, or we can nail the top in and then put on the lower stretchers. Let's put on the nails, just for something different. We'll take the clamps off here. And you can, if you want, just use screws, use drywall screws, but instead what I like to use are cut nails. And these are masonry nails. These are 8-penny masonry nails. And if you go to a real hardware store, not a home center, you'll find these for about $1.50 a pound. And that's a great bargain compared to what you would spend at a reproduction hardware store. And it's a 1/3 or 1/4 the price of what you'd pay if you bought these at a home center. Now that's the good news. The bad news about masonry nails is that they've been hardened, to go into masonry, and so you can't clench them, meaning you can't bend them over if you want to make a clenched door or something. These will not clench, I promise you that. We've tried it. So when you use cut nails, you always have to drill a pilot. Otherwise, everything's just going to split. And the other thing you have to be careful of is the way in which you apply the nail into the work. We have, with a cut nail, they are in their thickness consistent, but in their width, they wedge. And so what you want to do is you want to apply it in your work so that the wedge bears into the end grain. And so the wedge shape should be parallel with the grain of the board. Otherwise, it will just split the ends. Should be pretty obvious, but a lot of people get a little mixed up the first time they do it. Like I said, a pilot hole is critical. So we're going to lay out this where we're going to put these, and you know, might as well be tidy. So we're going to measure down 1 1/8 inches from the top of our legs, which should put the nails just a little bit below the center line of the top. And we want to leave this scrap up here. Don't flush up the scrap, because this extra meat up here at the top is going to help prevent things from splitting as you drive the nail. So it's a little helper. And then we're going to take our dividers or whatever measuring tool and make a couple marks on our line. And that's where we'll put our nails, 2 nails per. Some people will dovetail the nails, meaning they'll put them in at an angle. You can do that if you want. I would suggest you experiment with it first. I don't really dovetail all that much, dovetail nails, maybe a little bit, but in a case like this, you're dealing with enough angles to make it difficult to drive the nail, so why make it any harder? This is a 5/32 pilot. And I'll either use 5/32 or 3/16 for 8 penny. Let me take it. And then, as we always say, is hope this works. And that's all there is. So let's go ahead and do all 4 legs, nail them, and you can set them if you want to, or you can set them later before you plane down the legs. But we'll get through that, and then we're going to put on the lower stretchers and start practicing how to do half lap joints. Any questions about nails? All right. The next step is getting this short stretcher in place on the inside of our legs here, on this reference edge that we had planed at the very beginning. And we have 2 things we need to accomplish to get this working. One is this surface, these 2 legs need to be coplanar to each other so that this will sit flat on it. So the first thing I'm going to do is I'm going to mark on the leg approximately where the short stretcher is going to go. And that's 12.5 inches down from this corner. So take your long ruler or whatever and make a mark at 12.5. And if it's a little off from 12.5, that doesn't matter, but that's a good place to put them. And so I know now that this area, around in here, that these 2 surfaces need to be fairly coplanar for this to work. I'm going to cut half laps on the end of the stretcher, and I don't want to have to be tweaking, half laps to a weird complementary angle to match the complementary angle here. I'd rather have this be flat and these joints be flat. So in the end, what I'm going to do is I'm going to take this and I'm going to look for gaps. And I can see that this edge is high here, and I can see that this corner over here is high. So I'm going to take a block plane and true up these 2 surfaces until my stretcher sits flat. So I'm going to do that for both inside surfaces of the leg. And the other thing I'm going to do is I'm going to true up the stretcher itself with the plane. And because this surface meets this surface right here, or we'll say this surface because it looks better, is that this surface is going to be our reference surface and it's going to be our show surface because it's going to ultimately face out. So this is the case where your reference face and your show face are one and the same. So we're going to true this completely flat, and then the top edge, which faces up, is going to have to be a reference edge. And so we want to make sure that this edge is 90 degrees to this face. So that's the next stage we need to get to, is making this area ready for the stretcher and this stretcher flat and ready for the half laps that'll join it to the inside of the legs. So do that for both stretchers. All right? Okay. There are probably lots of ways to get the short stretcher lined up with the legs to mark it, but this is the way that I found works pretty well. I have marks, little knife marks at 12.5 inches down from the top. That's not a totally critical dimension. 12 inches is fine if you want to bring it up a little bit, if you're going to cut the legs shorter. But 12.5 inches works fine for me. So I'm just going to clamp this to the legs in position, like so. And then take a marking knife and scribe the shoulder line right onto the work. Measuring, bad. Fire, bad. Knife. Fire good. No, fire, well, if your project's really bad, fire good. But knife, good. And remember, several light strokes are better than one mighty stroke. Then unclamp it. And now I have, these angles, whatever they are. Are they 10 degrees? Who cares? So now we're going to work off our reference face, which is also our show face, with our marking gauge set to 1/2 inch. We want to make a 1/2 inch deep lap. And then we're going to knife in the depth all around. Then we're going to take our knives and we're going to drop that shoulder line down to our cheek line. So I'm going to drop the knife in, slide the square over, then drop the knife down until I can feel it drop into the cheek line. Same over here. Drop my knife into my shoulder line as a reference, slide the square to it. And this is also the most accurate way of taking a knife line all the way around a board. So knife in, square, knife down. Knife in, square, and down. And now it's just a simple matter of doing what we have done before, which is to cut this kind of like a tenon cheek. And anybody want to guess what class of saw cut I'm going to use here? First. I could use a first, but I'm going to start on a corner. So I'm probably going to want to use a second class saw cut to make sure that this is accurate. I mean, yeah, I want it to look nice, but I think that rather than knifing in all this, I'm just going to take one quick stab at that corner. You could do a first class if you like. Remember, waist towards the operator. And knife in the corner, a little hand pressure, come in, remove the waist, get a rip saw. This is a rip sash saw with about 10 points per inch. drop it into the notch, take all the weight off the toe. Use your thumb to extend this line all the way across the end grain until we get to about 1/8 of an inch deep. And then go to town, walking down the shoulder of the cheek here. Flip it around. Bring it down. Now you have to be careful because this is at an angle and it's real easy to, saw below your baseline there if you're not careful. So it's good to be able to see the angle as you're going down and getting that hump from the middle. This is a first-class saw cut. It's pretty visible, but it's also, we just need that accuracy because we really want the shoulder to be really tight up against the leg. So we're going to make a notch across that. Drop. This is a cross-cut sash. Drop it into that notch. Pretty clean. And I'm going to cut all of them, and then we're going to clean them up with a router plane so that they're all the same depth. So let's do all 4 of those joints, and then we'll come back and look at a little bit at how to clean those up with a router plane. Any questions?
Would it be better to cut that slightly shy of a 1/2 inch deep then if we're going to clean it up with a router plane?
I think that really you should never try to cut shy of anything. And I think you should always go for the line. It's easier to cut to a line, right on a line, than it is to cut a distance away from a line. So just go for it. If it's a little deeper, then it's not going to affect anything. But I think you should just go for it. All right? So go for it. Okay, once we get, our cheeks cut on the saw, what we need to do is, put the saw bench upside down on your bench, and then drop the piece in upside down like this, and you can get a read of how bad off you are pretty quickly. And I can see that I've got a little twist, probably from the saw cuts, because I knew everything was square. This surface mated to the legs, and now it's twisting. So I really want to take this to the router plane and true up these cheeks. Even though they look good, they're probably a little twisted. So I'm going to secure this and take my router plane, and it's set for a 1/2 inch deep cut and maybe a little stronger than that. And I want to make sure that it touches everywhere on my cheek so that these are coplanar. It looks like it does. So then it's just a matter of coming in, make sure that's locked, and truing up each cheek. And I'm using the other stretcher to support the unsupported end of the router plane. Try to definitely clean up all the junk in the corner of the shoulder. So that cheek is clean. And And so now we're going to make the other cheek parallel to it. Very handy. Router planes can't take a real big cut, but they can take a fairly sizable cut when you work across the grain. So they're mostly used traversing. And once you get that cleaned up, once they're flat, then I can shoulder plane. Some people will go to the shoulder first, but the problem is if this is twisted, you know, they're not going to get an accurate shoulder. So the shoulder plane is as much a measuring tool, I think, as it is a cutting tool. Is that behind the knife here, I can see when I lay this flat on the surface and I bring it up to my shoulder that I'm tight here at the back, and I have probably about less than a 1/16 gap up here, which means I have some junk up here that needs to be removed. And so what I'll typically do then is I'll come this way and work towards myself so that I don't have to blow out the bottom. And I want to remove that junk until I have no gap. And so that's how shoulder planes work, as a sort of measuring device and as a cutting tool. So this is your little 6-inch machinist straight edge. So let's take a look at this one. Got pretty much the same situation. Where down at the bottom I have a gap and I'm tight down here, so I'm going to and then I'm going to show this to the work. And I've got pretty tight shoulders on both. And I want to make sure I've got tight shoulders if we're going to put this on camera. And now I can glue up. Now you can nail and glue up if you want to at the same time, but I always think it's better to let it at least sit in the clamps for a while. So we're going to put some glue on each cheek. Drop it on in place, and then just use some F-style clamps to hold it in place for a while. That slid around on me a little bit. That's good. So yeah, these are kind of like winding sticks. You know, in that you, that's going to be good enough. So we'll let that glue dry, and we'll come back in about 30 minutes and nail it. Then we'll move on to the stretcher that joins the two. The glue's dry, the clamps are off, and so now we're going to nail these stretchers in. Now you can get all kind of engineer on me and you know, try to scribe a center line down this, or you can just eyeball it, which is what I'm going to do. So I'm going to eyeball the angle like that. Then I'm going to come in with my dividers and do that. Take my brace and come in. Then take a 6-penny masonry nail, and remember, we want it to cut well, the wedge part to bite into the end grain of the top board and then just drive it home. Do that, 2 nails in each joint, and then we're going to work on the center stretcher. So this will just take a minute or two. We're getting close to the end now here, and really the last piece we have to get in place is the center stretcher. And the center stretcher is critical because the reference surface is actually the edge. It's not a face, because this is the surface that has to mate with these. So what we want to do first is we want to take our stretcher and dress it up so that this edge is true, completely flat, and that these faces are 90 degrees to it, both 90 degrees to it. That'll make cutting the lap joint a lot easier. Now, you have the opportunity at this point when you're dealing with the stretcher to add any decorative detail that you might like. On this one I put chamfers, through chamfers that were just cut with a chamfer plane. The other option that we're going to do with this one is we're going to put an OG on the ends of this one, and so in the end it'll just have an OG sticking out there, and that makes it fancy. So to do the OG, what we're going to do is just take a little pattern. An OG is just an S-shape curve, and lay the pattern on there and trace around it. And then we're going to take a coping saw, because that is the saw that is handy, and I don't have a bow saw, which would be my other option, with a thin enough blade right now. So this will do it, but it'll be a little slow. And then I can just take a rasp and clean up to the line. So let's get this all dressed up and cleaned and ready to go, and then we will work on the half lap notches that'll join the stretcher to our short stretchers. I've got some twist in these boards, and I could spend a lot of time trying to flatten these out and it'll look like dog meat when I'm done. So I'm not going to do that. Instead, I'm going to cut notches that will be all crazy angles, but we don't care what the angles are because we're just going to be able to draw lines and cut to them. So these are going to be some of the strangest angles of the whole class here. So what I've done to get things in the right place is I've scribed a center line on the underside of my stretcher, and I have center points lines scribed on the show faces, which are also the reference faces of the short stretchers. And so first I'm going to line up my center lines with those center lines. And that's good. Now, because I'm going to be doing a lot of crazy knifing, and I have some twist, I don't want to make half of the cuts or half of the marks with it this way and half of them that way. So I want to lock this down. I want to choose one twisty angle or the other, and not both, because both won't work. So I'm going to choose this one because it looks less heinous. And clamp it down so that it won't twist. Now it won't move. Double check everything here. Okay. Looks reasonably good. And so what I want to do now is I'm going to take this face and scribe the shape of this onto this. So I'm going to come back here with my pencil behind. So now I've taken this face, and this face will enter this at this angle. If I go up the other way, and now I'm going to scribe the shape below onto the shape above. And then I'm going to repeat the process over here. So I'm taking the shape of the lower stretcher, its angle, and putting it here. And then taking the shape of this stretcher and putting it here. So I'm going to repeat that on all the joints while this is clamped up. And then we're going to connect those dots, and then we will cut the notches in both, and it'll go together. It will. Yeah, you're looking at me like I have two heads, but it works. It works. Famous last words. Okay, now that we've got the marks laid out all over, we can move on to cutting the notches. So I have the lines for the walls of the notches, so I'm going to take a 1/2 inch gauge and connect those lines. And then I'm going to use a ruler to connect these lines. Don't use a square because chances are this is not square. This is the opposite of square, which is similar to being the opposite of horse. I don't know what that means. Okay. Over here and do the same thing. Looks good. And over here. Put a little pencil line in those. And now I can cut those notches. And this should all be rote by now. I'm going to use, now this isn't going to show at all, so I'm not going to really do anything. You know, only the bugs and insects that crawl through my shop will see if there's any blowout or tear out here on this shoulder. So I'm not going to knife it. I mean, you can go all first class on it if you want, because you know some people care what the bugs think about, and but I don't. Now I want to cut this shoulder here first, and follow that line, and then follow this shoulder, which should be the same, but just want to watch it to be sure. Good. Then we can pop that out with a chisel. And then clean that out with the router plane, which is still set for a 1/2 inch depth. And so we're going to just clean up the bottom of this notch, do the other notch similarly, and then show this notch to the notch that we're going to create on the short stretchers, just to make sure that everything is a-okay. Now we're going to saw the notches into the short stretchers that are going to receive the notches we just cut in the long stretcher. So that means we're going to have to saw directly into our assembled project. Now, the best way to do that is to take a batten, a piece of 2x4, and clamp it to your bench. And that way, when you're sawing into your bench, you can, the force of the saw will keep the saw bench in place. That means you don't have to clamp this 10 ways from Sunday when you're working. It's just a real simple way of working. So the first thing we're going to do is we're going to connect these lines. And this is the wonkiest one. This might be the wonkiest saw bench I've ever made. So we'll see if it goes together. So now I'm connecting the lines left over from my layout earlier. Now I'm going to take a crosscut saw. This is a crosscut sash. And I'm going to saw. And I want to leave the pencil line. I don't want to split the pencil line. I want to leave it alone. Hit it back there. All right. Now, the best way to chisel out this waste is to do it flat on the workbench and just pop it out like this instead of up in the air. Get as close as you dare to your knife line, and then finish up things with the router plane. And most standard router planes will actually fit in here. May not be able to get all the way into the corners, but to be able to establish most of the floor and then come in with a chisel and use the floor established in the middle by the router plane to finish up the corners. Next step is real quick. We're just going to put some glue into the notches. And then just put a little clamp pressure on it for half an hour. You can nail it if you wish. Put a little decorative nail in there, though it's not really going to do much. This half lap is doing most of the work. So once that glue sets up, that is pretty much all the structural part of the saw bench. And then we can take a flush cut saw and flush everything up, and then we will true up the legs. Don't have a flush cut saw. Now we're going to get to the part that is the most fun for me, which is leveling the legs so they sit flat on the floor. And it's a compound compound angle cut at an angle. Pretty, freaky cut if you wanted to try to do it on a table saw. Pretty easy cut to do with a handsaw. The first trick is you really want a level platform to work off of. So either find a place that is level in your shop, on like the floor or your table saw or whatever is level, or you can take a piece of, this is a panel and I leveled it on my bench because this floor is really way out. And then you want to shim up the bottom of the legs so that this top is level. And so what that means is that this will always be level to the floor if you have a flat floor, which is, of course, almost never. But hey, we don't want to not make it level. So I can see from this that I'm pretty close. So I need to put a couple shims under here to bring my bubble to the middle. These older levels are slower than our modern levels, but sure look pretty. It's actually an inclinometer, so you can set it for any level that you want. So now this says I need to bring both of these feet up. So it's a little process of back and forth. Okay. Now, we know that since this saw bench is going to be for me, that it needs to be 19 3/4 inch high. And so what I'm going to do is get a block of wood. It's a nice looking block of wood. Ooh, look at that. Very nice. I'm going to set that up here. I'll do this so the camera can see it. And then I'm going to go to 19 3/4 inch high here. Pinch it. And that's the block that I need to mark all my legs. Okay. This edge is the best, so I'm going to use it. Mark that one. And now I just take this block and use it to trace lines all the way around. Fairly awkward, but doable. Now we just have to saw each of these legs to length. Then do the other three, and with any luck, it'll sit flat if you find a flat spot. Any questions? Hopefully yours goes a little faster than mine. Yeah, that's the bottom.